Can chemistry crack the mystery of the origin of life? That's our question today. How on earth did life begin? We're quite literally asking that question on the show. How did inorganic chemicals in the primordial soup of early Earth become living systems, capable ultimately of developing into human intelligence? Three distinguished guests with different perspectives join me on the show today. They're all keen to find an answer to this. Going to be joined by Lee Cronin on the show today. He's Regius Chair of Chemistry at the University of Glasgow. He and his research team have pioneered new chemical experiments seeking to effectively sort of fast forward the conditions on Earth that may have gotten life going. He's going to explain why he believes understanding chemistry is the key to this mystery. Denis Noble is a noted Oxford biologist who's been critical in some ways of the neo-Darwinian view of evolution. 3 years ago, he organised a conference at the Royal Society exploring new third-way trends in evolution, and he's got an interest in this area. Perry Marshall is the sort of person responsible for bringing this show together today. He's got a background in computer science. He's something of an entrepreneur, and he believes that understanding where biological information came from is the key to the origins problem. He's established a $10 million Evolution 2.0 prize for anyone who can crack the mystery of how life got started. So, can we find a purely naturalistic explanation for the start of life? Is there maybe room for a guiding hand beyond merely physical processes? That might come into our conversation. Be very interested to hear the perspectives of my three guests on the show today. So welcome along, Lee, Denis and Perry. Perhaps, Perry, we'll begin with you because you sort of suggested this meeting of minds today. Do you want to tell us firstly about the problem, first of all, the origin of life issue, and about this big cash prize you've organised for anyone who can crack it?
So I went down the rabbit hole of where did life come from about 15 years ago, and I started investigating evolution. And I found that while evolution was an incredibly complex and detailed subject, where did life come from was actually much simpler. And it was simpler in the sense that nobody knows where it came from. There's lots of stories, there's lots of theories. In fact, one time I was listening to an NPR program and Richard Dawkins was on, and somebody called in on the phone and they said, "So where did life come from?" And Dawkins said, "It was a happy chemical accident." And I listened to that and I thought, did he actually say that? And does he actually expect us to believe that that's a scientific theory? And he's a professor of the public understanding of science. And I felt that it was really an anti-scientific answer. And I started reading Origin of Life books, and I was disappointed at the lack of rigor and the willingness to really just kind of go along with a certain amount of fiction. And so on the other side, I was very sympathetic towards the intelligent design view, and I really embraced that for a while. And I had a great God of the gaps argument. But over time, I started to feel that if you just said God did it and that settles it, you haven't really settled anything. And you've really damaged science as well, because a scientist can't say, well, God did it, let's put that in a paper and let's go out to lunch. And so what I decided to do was create a technology prize, because these kind of prizes have been very successful in other fields. They brought a huge breakthrough in space flight, for example. And I said, let's put money on this thing and let's get people really trying to solve it. And so at the Royal Society in May, we announced a $10 million prize. It was announced at the Financial Times website, and we've had other media outlets cover it, and we're looking for an answer.
It's fascinating. And Perry, you're the kind of guy who I can just see instigating this kind of a search and putting some money behind it. Denis, you've endorsed this prize yourself. You're one of the judges, I think, as well. Tell us a little of your background, firstly, and why the origin of life issue has become such an object of fascination to you.
Yes, I will start by making a very simple factual observation. I suspect that many of your listeners will think that life depends entirely on DNA. That's one of the molecules that contributes to our genetic inheritance. Now, I'll tell you an interesting fact. If I could take the complete DNA out of one of your cells and I put it into a Petri dish, that's the kind of dish that people use to study bacteria and other little bits and pieces. So we put it there with as many nutrients as you wish. I could keep it for 10,000 years and it would do absolutely zilch. DNA as a molecule is one of the most inert. RNAs, which are formed from the DNA template, they're more interesting. They can actually be catalytic, as the chemist will say. They can actually make two molecules interact with each other faster than they would otherwise do. That's a key. You need that to have any living system, to make things go in a particular kind of way. Now, what that means to me is that it's extremely unlikely, really unbelievable, that DNA was there at the beginning.
Right.
And that's one of the reasons why, just incidentally, I think your other guest tonight, Lee Cronin, is on the right track by not starting with DNA, but starting with what are called polypeptides. These are little molecules connected together called amino acids. Let's not worry too much about the technical language. The key to them is they're very good catalysts if their shape is right. And so I think he's right to start in that way.
Well, I think we'll obviously dig into this as we go along, and I want to sketch out the big picture first of all for listeners of what's at stake here and why this has obviously foxed so many people up till now. Lee, great to have you on the programme today. I should say, when you walked into our studio, you were like, oh, it's a Christian radio station, is it? And if that wasn't made entirely clear in our previous correspondence, I apologise. But I'm taking it you don't have any religious views yourself or faith to speak of in that sense.
No, I mean I'm a scientist. I like evidence, and I like to have discussions where I can have arguments about evidence. That doesn't mean I don't dismiss people who don't argue with evidence, but that's a different system. And
sure. I'm all in favour of evidence too. As a Christian.
So I think you can. I have many Christian friends who are brilliant scientists.
Yeah.
Being religious doesn't stop you from using evidence. Absolutely. It just means that you have another belief system there as well.
Okay. That maybe not specifically scientific evidence, I suppose.
Sure. I mean, we all have belief systems, whether we declare them or not.
Right.
This is part of our discussion earlier. I mean, I think this whole question is really interesting because, of course, there is a mystery, right? We're kicking things down. And I would like to make a couple of assertions or a couple of comments.
Yeah.
There is an evidence that there was a thing called the Big Bang, right? We can argue about that. And then after that Big Bang, there was stuff in the universe and that energy crystallized, if you like, into hydrogen. That hydrogen then crystallized into stars, right? Those stars burnt, exploded, and produced carbon. And that carried on. We produced some heavy elements and we have some planets. And those material on those planets turned into biology. I would like to make an assertion. I agree with Perry about the being annoyed, I think, confused by the assertion that life was a happy chemical accident. I can tell you that if we haven't proven it yet, and I think we might have already done this in the lab, and say that the emergence of life in chemistry is as inevitable as the emergence of stars in a universe where there's matter. Now, we understand that gravity produces stars. Now we need to understand what is the gravity in chemistry that produces life. And that is partly what I've come here to kind of tell you about today. It's really exciting because we've had some breakthroughs in the last few weeks, actually.
Oh, really?
And I want to push Perry on the criteria for the prize.
Okay, so you think you're in with a chance of this $10 million, do you?
Oh, I think we'll win it if he's got the right, if he's willing to give it, right? I mean, but that's a discussion we can have, and I'm really excited because I take my hat off to Perry. He's seen a gap, identified a problem. I'm going to take that prize at face value and try and do my best to win it.
Well, look, we'll get Perry back on about that in a moment's time. Just sketch out the big picture here, because a lot of people assume, maybe they learnt this in GCSE biology or something. But, okay, so there was some kind of primordial soup billions of years ago on the surface of Earth. Chemicals swimming around, maybe bolts of lightning going off, and somehow something happened and poof, you've got your first sort of very simple cell or something swimming around in the ocean. Okay, that's my GCSE vague recollection of what might have been explained as how life got here. Is that view essentially correct or fundamentally wrong? What's the big problem that people have, why they haven't, up till now at least, been able to give a sort of naturalistic scientific explanation for how all those right bits got together to create life?
So a really important. So you're not wrong. Your GCSE chemistry is not too bad at all. But planet Earth wasn't just this magic melting pot of magical chemicals. It's the same planet now, but it's got life on it. And the problem we have with looking for life on Earth right now, the origin of life, is there's already populated by our current biology.
Yes.
So cells emerged and created an ecosystem, and there's DNA and RNA and bacteria all over the planet. And they have terraformed the planet, from bacterial mats in the ocean to human beings burning forests, building aeroplanes, runways. So it's very difficult to go back and ask, where did life come from when life is polluting? So that's the first point. But the second point, I would say that actually there is nothing magical about the emergence of life. It's really simple. And what we've got to try and do, and I really like, again, coming back to the prize and the idea of where does information come from, universes without life are universes without information. Okay, and I think Perry and I really agree on that point, but I'll let him comment on that in a moment. So what we're trying to do is we're trying to produce a system, a chemical system that produces its own context. Now, I don't like that word, and your listeners are probably like, what do you mean by that? And it's a bit like, what happens is the chemistry is random, okay, until a chance event, and that's not a lucky event. That means an improbable event on a probability distribution. Like if I play cards, I might get a royal flush, but I'd have to calculate how long I have to play randomly.
Yeah.
Once I've got that royal flush doesn't mean to anyone unless I'm playing cards.
Yeah.
But suddenly, if that royal flush itself created the player to recognize royal flush, you have a feedback loop. So actually, when you then remove the need for magic random, it's any random.
Okay.
Any random event gets trapped in a bubble, in a rock. And that then allows to another random event to be slightly less random because of what's in that rock. Because you've taken a coin and you've weighted it, so you get slightly more heads and tails. And then that coin is able to make other coins that are slightly more heads and tails. Before you know it, you're only flicking heads. So what you can do is you can do a model and show how many times do I need that to happen for I always go from heads and tails evens to always getting heads. And that type of discussion is how we're creating experiments to create life.
And that's what I was going to ask. This is essentially what your experiments are trying to model, kind of flipping that coin however many times until you...
Well, not just that, it's also getting... So what we're showing in the lab is that we can have random chemicals that emerge that make their own code, but then that code is only a code if they can read it. There's no point in, if Denis starts writing, he's writing in an odd language here I don't recognise, but if suddenly I'm able to start reading that language and I can decode it, we're on to something.
Yeah. How are your experiments different from the Miller-Urey experiments of the 1950s where, they basically put chemicals and put electric currents through them and said, oh, look, we've produced some proteins. And I think that was by and large discredited, if I'm not mistaken.
It's not discredited. It was basically people were saying that the Miller-Urey experiment was like the negative pole of a battery. It was reducing. And we need a positive pole as well, like a positive. So, and where it's oxidizing. And there's lots of arguments about that. And I think, again, Perry and Denis are right, that there's lots of anthropomorphic kind of, we want to basically make life in our and I would also back Denis down a bit and say it's even nothing to do with amino acids. What's going on in my lab, and there's one important thing that we're doing, is we're adding history. So all we're doing is Miller-Urey-like experiments, but we're remembering what happened. All that biology is chemistry with history. Right now we are forced to use DNA as our tape. Now what we're doing in the beginning is showing how we can use the soup to remember itself. And that's very inefficient, and it loses memories and forgets things, but over time becomes better at remembering. If you're better at remembering, you persist, You don't get erased when a comet hits you or whatever else is going on Earth. And before you know it, you've emerged your own error correction system for your code.
Okay. Before I bring Denis back in, Perry, what do you want to say to this? Firstly, are you willing to give this money out if if the conditions are met? And do you think Lee's getting along the right lines? I mean, he says at the end of the day, it's actually quite a simple problem. It's not as complex as people make out.
Well, the prize money is quite real, and we've got a group of us investors who have signed in blood that they're going to write big checks, and the net worth of the investor group is actually about $1 billion.
Okay, so this is small fry for them.
Money is not
Great.
A problem.
Yeah.
Really, our biggest problem is just not getting enough applicants and not getting enough word out there about what we are doing. Now, I like what Lee is doing. Lee, I really enjoyed your paper about pathway assembly, which is where you are recognizing the information is a core entity to the whole process of life. And I like Sarah Walker, of course, which you co-authored that paper with. And just for everybody's benefit, what pathway assembly says is there's a certain minimal set of instructions necessary to assemble chemicals in certain orders and certain sequences. And since biology is the only known source of agency, then if there is a discernible pathway assembly, then therefore there's agency involved. And so Denis and I have had a lot of conversations about how what this prize really is it's a search for the origin of agency, or the ability of a system to act in its own self-interest. And Lee and I met in Santa Fe at a Santa Fe Institute event, and we had a really great conversation. And, I, like Lee, when I read your work, I feel like I'm dealing with somebody who doesn't feel the need to excessively fictionalize or romanticize what they're doing. And I really appreciate that.
Denis, what's your view overall of Lee's project here?
Well, first of all, I like the way he put it, because he started with that very improbable event, a royal flush, I think you called it. And I like that idea because it's not saying that the nature of that arising is completely unbelievable. It's just saying that it has a certain probability. Now, I like the second thing he went on to say, because I would describe what he was then talking about, how you move from extremely low probability to very high probability, possibly getting your heart all the time or your head all the time. And I call that harnessing the stochasticity. That's a long phrase. Harnessing is like you harness a horse. It controls it. Now, the big difference between people like me and the neo-Darwinists who propose that there is chance and then just selection by natural selection is that I think the chance is used.
Okay.
And it's used by biological systems. And you can prove that. Our immune systems are doing that now as we talk. If a new invader comes and invades our body, another virus, a bacterium that we haven't met before, what do? We start playing around with the chance down in a particular region of our genome to create the antibody to that invader.
But my understanding, and forgive me, I'm certainly the layperson in this conversation, was that you kind of have to have a DNA or something like that for evolution to begin. You've got to have that in place for mutations and whatever to then be able to play into the system. But you're shaking your head at that, Lee. So what have I got wrong there?
So I think the really interesting thing about evolution and life is we don't know what they are yet, right? We have a little bit. We have a little bit of how they work. So I mean, we know what evolution is in the context of biology.
Okay.
It's a bit like flight. So before, if you could imagine a world without aeroplanes or helicopters, and you said to somebody, "What is flight?" they would look at a bird and say, "Well, that's flight," or a bee, or maybe a hot air balloon. But now flight is, for me, a successful flight is getting on a plane at Heathrow and maybe ending up, say, if I'm going to Arizona and Phoenix, right, on a 747. And flight is defined by machines that can do work to create lift. And so we actually then have a theory for that. So the problem we have right now is we don't really have a theory for the emergence of evolution, but we have a theory of evolution that operates when we already have a memory.
Right.
And that memory is basically DNA. And actually evolution doesn't happen in DNA, it happens in cells, in populations. And I think that's something that the population biologists have really taught me. So now I have a population of molecules. Those molecules are in different states. Those molecules are partitioned in and out of a cell. I make salad dressing a lot in my lab. And in fact, salad dressing is probably the most important thing for the origin of life. That is oil in water.
Okay.
What happens when you shake oil in water? You get bubbles form spontaneously. Some molecules can dissolve in those bubbles in different ways. And each bubble has a different set of molecules in them, and you can fingerprint that using a device, similar to what you'd maybe test your blood to look at.
Okay.
So if every droplet is different, suddenly you have individuals. If individuals are now interacting in those droplets all bashing around in that salad dressing, they can compete with each other, they can cooperate together, and they can start to record stuff.
But we're still talking at this point about inorganic chemistry, right?
Correct.
So and I suppose that the thing I'm trying to get my head around is it feels like there's a big difference between a chemical which has no sort of teleology, that it just is what it is, and a system which kind of has this trajectory, if you like, to start replicating. And
so that's a really important point you're making. So for me, teleology is a word I only learned a few months ago, but actually I now know what it means, so I can talk to you. So I would say, like, if I design a fork to pick up something, I know it's a fork. But if I observe a fork arising and I look at the pathway assembly of the fork, I'd say, well, actually it's below my threshold, it could have emerged, but an agency built that fork when I can discern a number of features. So what I mean is chemistry is at the border between teleological, if that's a word, and teleological system. And when the chemistry is able to create it basically is able to affect itself in the future, that then becomes teleological. Right.
It crosses over from inorganic to organic.
Exactly. And that's really the exciting discovery we're trying to make. Perry wants to pay for. No, I mean that in a sense, not just my lab, but anyone's lab competing. He wants to see, and I'm putting this precisely so he can challenge, and Denis can challenge, that a self-generating system that's teleologically generating objects. And what you're saying is like, oh boy, DNA, we're convinced it evolves, but how did that happen?
Sure.
And I would say evolution occurs firstly in bubbles, right, over the bubbles. So you imagine like a massive system, disorganized chemistry persisting. As that persists over time, it has to compress those features and stop errors creeping in. And what happens over time is polymers get formed. So what is a polymer? Polymer is when two ping pong balls, if you like, are able to come together and rather than bounce off one another, they connect. And then it's two ping pong balls connected together. So you have double the information before and so on. And you get the kind of daisy chaining.
It's extraordinary. And in a way, it sounds like what you're saying. If it's possible for life to arise, it will arise.
Correct.
Effectively. There's a kind of principle at work by which that's the direction things will go.
Sure.
If the physical conditions are simply possible.
I'm pretty sure by the end of my academic career, if not earlier, we'll show that the emergence of life is inevitable as a discovery of exoplanets.
Well, you're a confident man, and I guess you need to be when you're dealing with these kinds of areas. It's a sort of like, it's like you believe you've got the theory, and you're going to follow it through.
Yeah, I mean, the only belief system I have, I guess, is the belief that chemistry is not magic. So I'm believing there's nothing magic in chemistry.
Right.
And so I've got to set up those experiments and look at the emergence.
Just before we come back to Denis, Perry, just you said, well, this is all about agency ultimately and information. Do you think that Lee is got this right, that there is this kind of simple principle that if if the conditions are right, life will happen because there's this, I'm not expressing it well here, but there's this, that the teleology will kind of kick in as the different ways in which it can be expressed kind of are found in all these different combinations. What's your view on that, Perry?
I don't know. I'm open to the possibility that this exists, and I'm open to the possibility that Lee can prove this, and I'd love to see it happen. So far, it appears to me, as far as I can tell, that whatever makes life happen or whatever makes information happen is akin to some other law of physics that we've never understood. And Lee and Sarah's paper talks about that. And Paul Davies and Sarah have done all kinds of work around that issue. And Denis contributed to a book called From Matter to Life, where they explore that question. And so, like, I'm open to the possibility that Lee can figure this out. And Lee, like, I think, as far as I can tell, if you figure this out, then this is like you're the next Nikola Tesla or Albert Einstein, and this is the next E = MC squared. Because it seems to me that it's something entirely different than what we currently understand.
I mean, quite apart from the Evolution 2.0 prize, I think the person who cracks this is open for a Nobel Prize. You know, this is big stuff. We're going to come back in just a short moment to you, Denis, because I want to get your thoughts on this as well. We're just going to our first break, and we're asking, can chemistry crack the mystery of the origin of life? So delighted to be joined by three people who really know what they're talking about, someone who really doesn't on the show today. But I hope you're enjoying our conversation, and we'll continue in a short moment's time. For more conversations between Christians and skeptics, subscribe to the Unbelievable podcast. And for more updates and bonus content, sign up to the Unbelievable newsletter. Welcome back to today's show. I love it when I get to sit down with people who are just experts in their field, and my job is to kind of try and bring it down to the level of the ordinary layperson, and I hope we're doing that for you on the show today as we talk about the origin of life. How on earth did life begin? That's quite literally the question, because at some point life started on Earth. But we're still trying to work out what happened, because it presents a lot of problems. A lot of people have said the probabilities are just so astronomical. It's very hard to see some kind of naturalistic explanation. But Lee Cronin, who joins me on the programme today, says no. Understand the chemistry, that's the key, and he's doing the experiments which he says are going to win the Evolution 2.0 $10 million prize that Perry Marshall and Denis Noble have come in to talk about today. Denis, you've obviously been working on this yourself on the sidelines to some extent. What's going on? We've heard lots of different words here. Teleology, which essentially means a sort of purposive process.
Indeed, yes.
Agency, which means
same
that there's
thing.
same sort of idea. Information, and of course all the chemical processes as well. So can you frame this in a way that is perhaps helpful for the listener as to what you think is at the centre of this enigma that is the origin of life?
Well, I think I'm going to do that by first using the title of your programme, which I believe is Unbelievable.
That's correct.
And I'm going to make a very unbelievable statement. Okay. At least I think it will be unbelievable both to neo-Darwinists and to most of your listeners. And that is, the very existence of DNA requires teleology first.
Okay.
Now, that may seem very strange because many of those who believe the idea that DNA is the centre of life, it's what directs the whole process of producing the organism, which is, I'm afraid, untrue. It's actually a complete cell that is the beginning of life. But let's leave that to one side for a moment. What I mean by DNA requires teleology first, it's an incredible process, the way in which cells handle our DNA. When the DNA is copied to be contributing to two cells and the cell dividing, which is an essential part of the development of the organism, then what you find is that the natural error rate in that copying is very high. It's 1 in 10,000 of those ping pong balls that I forgot. Lee. Yes. A very simple name, and I forget it. Anyway, it's one of those ping pong balls, you see. And but imagine 10,000 of them, and you get an error. Now, it may seem very rare, but
that's
we've
actually
got
quite
3
high.
billion ping pong balls.
So that's
now,
quite a lot of errors.
That is over 100,000 errors. No organism will be able to survive that. What does it do? The cell comes along and it corrects those errors. And from 1 in 10,000, you get 1 in 10 billion.
Wow. which is quite a low rate.
It's extremely good because most genomes are therefore copied completely faithfully. Now, why do I say that requires teleology first? The cell is a teleological structure. It knows, and I use that word advisedly, it knows how to copy itself. That's what Lee is trying to do in creating the chemical conditions.
But he's taking it back a step to the inorganic point.
Indeed so, and I respect that, and I like that, but I'm just establishing first that it cannot be the case that DNA, as we know it today, was there at the beginning. First of all, it's inert. It needs activating by the rest of the system to do anything at all.
Yeah.
Second, it has this terrible error rate, which our cells correct all the time.
So you need the cell for the DNA to be worth
Absolutely
doing
so. And that's why I
with.
say the DNA requires teleology first.
And in that sense, if teleology is there to start with, it's almost like, now, as you say, the neo-Darwinists will say you're putting the cart before the horse.
Exactly so. Yes, they do.
Because you're introducing something that seems a little bit mystical, almost, at the outset.
Well, I don't think teleology is mystical.
Okay,
over
but
to
Lee, why then?
He was saying that earlier on.
You're shaking your head at that, Lee. So go ahead.
So I mean, actually, I don't think Dennis's statement is unbelievable at all. In fact, it's entirely amenable to what we're trying to do in the lab. The thing is, this is where and I think I really share Perry's frustration looking at the origin of life, reading those books. Everyone's trying to make a soup that magically comes up with DNA, RNA, or assembled proteins. It isn't going to happen because there's an information catastrophe. And Perry's alluded to a paper that I've written that talks about a threshold where we're looking for living systems. But what that paper is allowing us to do is make a life emergence detector, which I've made a detection system that allows me to spot flight when I haven't invented a flying plane. The Wright brothers only went a few hundred yards in a wooden thing with some bicycle pedals, right? You're not going across the ocean in that. And so what I'm trying to find out is the lineage of chemistry that makes the most primitive rubbish machine that isn't a machine, it's a random ensemble. But as soon as that random mess is able to copy itself, and we've actually got one, I'm just publishing it right now, salt that makes itself, a actual table salt that can self-replicate from nothing. Now, you think about that for a second. Not only can self-replicate, but its children are just ever so slightly more complicated than the parents. But not so complicated that they're impossible to get. And that, if you carry on making those templates, if you like, you start to get towards the sophistication of DNA without requiring to be there.
So what's happening there? Because inevitably we kind of tend to anthropomorphize this salt as though it's, the salt wants to do this and it's going to do that. And that's unhelpful sometimes.
And we need to look. And so what I'm trying to get is the emergence of anthropomorphic behaviour.
Yes.
In a completely different way. And that's that's nice, because it's almost like metaphysics squared. So what is like the metaphysics of metaphysics, right? Or the politics of the B word.
Yeah.
So what I mean is that Denis and Perry are both right that DNA is a ludicrous molecule to expect to spontaneously form. That's not actually good evidence for a creator. It's evidence for other primitive living systems that no longer exist on Earth. It's a bit like in the lineage of computers. I've been designing computers all my life. But if I was to obliterate all the computers on Earth right now, we'd have a problem, because we need a computer to build a computer. So I would ask, what is the simplest computer I can use to build a slightly more sophisticated computer, build a more sophisticated computer so I can make silicon chips again?
Right.
And I'd get all the way back. And that is exactly what we need to look at with DNA, which is what is the simplest machine that makes another machine, that ends up with DNA.
So again, my stupid question at the base of all this is when this simple salt molecule effectively reproduces and some of its children become slightly more complex salt molecules, and then the complexity kind of builds and builds. Why? What's the benefit of that happening?
So this is where the new physics comes in, right? The problem with, if you go back to the Big Bang and I write down the equations of physics, you'd say, how the universe would unfold. Yet none of those equations would predict life. And that's really infuriating, probably to Perry, to Denis, and myself. And so what we've found is that there is a missing phenomena, which I'll call assembly. And what happens is the universe likes to assemble things. Now, you can see that on Jupiter's spot, right? You can see that in hurricanes. So what the salt is doing is it happens to find a motif that fights against error. Because when the wind blows the sand away, because it's resistant to being blown away, it can make itself, so it can still exist. All life is pretty boring, actually, when you think about it. Life is a complex chemical system that can persist over time. And if you erase it, it's no longer there and you don't care. So what I'm saying is that salt that can make itself can recruit other salt molecules or salt ions to assemble, and they are now resistant to being erased.
But see, I kind of understand that argument on the biological evolutionary side, because there's a sort of sense in which that there's a will almost in even the simplest organisms to reproduce. But
no, I mean, it's the same phenomena, right? There's a missing physics of information which connects physics and chemistry, and we try and understand the heat death of the universe. And that's a really interesting problem to try and join together. There's a lot for us, but life is not that special. It's just a manifestation of chemistry. I mean, here I'm kind of not all matter is equal, right? If equal, I'm holding a bottle of water. I own that bottle of water. I could destroy the bottle. I could drink the water. This matter's inanimate. I'm sorry.
Yeah, it doesn't really matter.
It doesn't matter. And so what we're trying to ask is, what makes matter?
Yes.
And that's that informational imprint.
It's the... Okay. Perry, what do you want to say to all of this? There's lots I'm sure you'd like to respond to.
So I think the key thing that he said was there's a missing physics of information. And I am very enthusiastic about somebody who can solve this. And I think this is great. I have to admit to being a little skeptical that Lee has solved it. Totally open that maybe he did. I again think this is akin to like discovering a new law of physics. I think this assembly that he's talking about, like he's right on track. And I have to commend Lee for bridging the information and the chemistry worlds together, because so at the Origin of Life meeting at the Santa Fe Institute at Stu Kaufman's house, there's like 4 or 5 chemists and 3 or 4 physicists and some biologists. And the chemists had a very different view of everything than most of the other people in the room. And it was actually kind of difficult for different parts of the room to talk to each other because they were approaching it so differently. So the fact that you're doing an interdisciplinary bridge between these two fields, I think is great. And I'm not in a position to comment on how successful you've been so far, but I like the work that I've seen.
Okay, so you're hopeful that this might be a new way into the issue and could bear some fruit. I mean, for you, what are the sticking points? Where can you see it potentially coming unstuck? And maybe Lee can respond to that. I mean, you've always been, ever since I've known you, Perry, and I know your views have changed over that time, but you've always been about the information and about the fact that you kind of have to have information right at the beginning to be able to have something that kind of makes sense from that point on. You don't kind of, there's no free lunch. You can't get information just spontaneously appear in that kind of way. So talk to me about that issue and how it pertains to this problem, and whether Lee has a chance of kind of solving that issue for me, Perry.
Well, so information is abstract and symbolic. So the words in a book are formed from paper and ink, but they are not ink. And in DNA, in the genetic code, GGG is instructions to make glycine. It's not glycine. And there's a symbolic relationship. And nobody knows how to get from chemistry to symbolic relationships. Now, if Lee's got that, you're gonna get a lot more recognition than just getting $10 million. And it's really extraordinary. I have some caution that you're making it sound too easy, but I don't know what you accomplished in the last few weeks. So I remain willing to be convinced.
Okay. Whatever that salt is, it's not going on any fish and chips anytime soon, I suspect. One thing that I know that you're very concerned about, Denis, is as we search the stars and the planets for the possibility that life might exist elsewhere, we obviously need to be very careful we don't cross-contaminate with what's already happened.
Lee and I might disagree, but let's see.
I mean, what would it mean for you, Denis, if we did find even the most simple life or the building blocks of life, let's say, elsewhere?
Well, first of all, there are a lot of very important questions that are not yet clear. First of all, the code itself between the sequence of DNA and sequence of proteins, we know, as Perry's already referred to, that particular triplets code for particular amino acids. Now, an important fact about that code is it's redundant. There are far fewer amino acids than there could be from that code alone. There's only about 20, and you could easily have 32. Now, that means that each of those triplets code, put it the other way round, each of the amino acids can be coded for by more than one triplet. That's the redundancy. Now, does that really have to be there?
Right.
Could there be proteins with more than 20 amino acids? I can't see why not. And if we find life on wherever in the solar system, that's the most likely place we might find it, in addition to Earth, does it have, if it has a code at all, does it have just the 20 amino acids that we know of? Or does it in fact have no DNA at all? As I think we're postulating in this discussion, that it's extremely likely that if there are very primitive forms of life, there won't be DNA at all. I would like to know the answer to that question.
Yeah, so if we do, it won't necessarily look like life on Earth necessarily.
That's right.
And you're nodding your head in agreement with that, Lee. So
Yeah. Well, I just tell you, so the assembly thing, that paper that Perry was talking about, is really for me an important concept. And I want to take 2 seconds, if I may, to tell you about why we need it. So the Large Hadron Collider is arguably been one of the most successful experiments done, not just because of the grandness of the science, but the way it's been communicated. Yeah. So you've got this thing called the Standard Model of the Universe, which we believe is correct, or we say we've got evidence is correct. There's actually some wrinkles in it, but let's just accept that that's pretty okay. And that Standard Model says we have to for gravity to exist, there needs to be a particle. And that particle was called the Higgs. So then they took the Standard Model and they then worked that up and did a simulation, if you like, and they worked out at what energy to find it. Yeah. So then they devised an experiment. So they know the Standard Model, they know they're looking for the Higgs, they got an experiment, and all they did is they looked at that energy range, smashing particles together, and they looked for the Higgs.
And hey presto.
And they found it. So we're going to go and look for life, guys. What are we going to find? And then, Perry will say, we want this, and Denis will say, I want that, and Lee will say, I want... And we say, right, okay, damn it, we can't actually decide on what life is. So what I've come up with is forgetting what life is, but looking on what life does.
Okay.
So what does life do that's different to a non-living, say, planet? Well, life makes things. Now, it makes really simple things. So it could make carbon dioxide, and carbon dioxide from biology and carbon dioxide from inorganic stuff looks the same. But actually, you do something more important. You make complex molecules. You make cars. You make silicon processors. So if we look for objects that basically can't randomly form, have a creator, and I don't like using the word creator because then we get into this discussion about intelligent design, but I think actually I shouldn't be shy about having that discussion, because I think that
let's have it before the end of the show.
Many of your listeners will say, well, hang on, I have a belief system. I want to understand why you kind of...
Why you don't include that
Why
option.
you don't have that discussion.
Okay.
Exactly.
Okay.
So, but living systems tend to make stuff, be it other living systems or artwork. Take a Jackson Pollock. You know a Jackson Pollock when you see one. So but the thing is, if you go to Mars and you found a Jackson Pollock, you'd say, that's a random assemble. Now you say you find 3 or 4 objects that look really complicated, but they clearly had the same artist. You would know that Jackson Pollock had been to Mars, for sure. And so that's what pathway assembly starts to do. It gives you a metric. It then says there's this thing called life. We don't have a general theory for it, but we know there is this thing it does. Yeah. And now we have a way of going looking for it. And that's what we've been doing in my group.
And so if they did go to Mars and find, something that was approximate to that, basically your theory would be confirmed? It's like the Higgs boson kind of confirmed that theory.
Well, I would say if you went to Mars and let's put it, and you found 1,000 iPhones,
Sure.
and they all turned on,
Yeah.
and they all worked,
Yeah.
you could only conclude that Apple had started making iPhones on Mars,
Which would be completely believable.
or
at one
shipping
level. Yeah.
shipping them there. You wouldn't go, these iPhones just randomly assembled on Mars.
No, sure.
So I think that's what I'm saying.
Okay. All right. Let's come back to you, Denis. You say that actually you're really interested in the search for extraterrestrial life in that way.
Yes, because I think it would answer some of the big questions of biology today.
Yeah.
Yes.
Now, if we went out and, say, in our solar system and any others we might have access to, just couldn't find any sign of anything approaching, would that be strongly disconfirmational of Lee's approach, do you think, or...?
Not necessarily. We are an extremely tiny part of the universe.
Of course.
Even the whole solar system, even though it's vast in terms of the size of an organism like you and me, it's still a very, very tiny bit of the whole universe. Now, there is a theory that some forms of life can go completely dry and survive in space.
Okay.
This is called the Panspermia Idea. Now, I think this is close as science gets to being unbelievable. Now, but it is a theory that's been seriously held. It was first formulated, as far as I know, by Fred Hoyle, the astronomer, many, many years ago. And one of those who thought a lot about the...
And this would be potentially, some people have put this as an explanation for how life was seeded on Earth, that it came from somewhere else.
That's the idea, yes, indeed. And there is evidence, you see, for that, because some of the meteorites that have come down onto Earth from somewhere up there, we don't know where from, contain organic chemicals, and they can contain up to 70 different amino acids. That's 50 more than we've got on Earth.
I've got a feeling this was the premise of that Ridley Scott movie, wasn't it, where the architects come and birth life or something early on. But go on, Lee, you're desperate to get in on
Let me
this.
just add to that. So we've turned this pathway assembly idea into a life detection system
Right.
that we're making for NASA. We've also taken all the meteorites and analyze them using this detection system. And yes, you can make lots of amino acids, but they're all able to be made in a random shuffle of the card deck.
Right.
They're all random molecules.
Okay.
So although you can find amino acids on meteorites, they've just been cooked up in space. They have never touched life. They've never been anywhere near life. They are not life, but they might be used by life. Bacteria could eat meteorites, no problem.
So you don't think the panspermia thing is a going?
Well, no, I don't. I agree with Denis that this is almost as unbelievable as they come, but I haven't seen any, and I've certainly seen no evidence for panspermia. However, I won't just shoot it down because it's improbable or impossible because I don't like the idea. I think it's far easier to make life on Earth than transport life from elsewhere in the universe and put it here.
Right.
I think that life might have got going on Mars. A little bit of the chemistry search,
Okay.
and then it kicked out that chemistry.
Right.
And because Earth has got a bigger gravitational pull, Mars was in the habitable zone earlier, so it got cooking. So
Okay.
it did the pre-course for you, and chucked it on Earth where it made the main menu.
Okay, that's an interesting theory.
Maybe.
What do you reckon about that, Perry? Do you think? Do you feel in any way like there's a chance we could find life elsewhere, and what would that have to say to your search for the origin of life yourself, Perry?
I don't have a strong opinion about it. I'm probably roughly similar to Denis on this and Lee. Hey, if this happens to be the case, well, that's very, very interesting. On the other hand, there's a book probably 15 or 20 years old called Where Is Everybody? And it's a book about, where are all these aliens that should be so abundantly likely to occur? So I don't have a real strong.
I had probably getting on for 10 years ago now, Paul Davies on my show, it was around a particular anniversary of the search for extraterrestrial intelligence, and he'd written a book called The Eerie Silence. And I remember him saying effectively, well, life is, he said life is at one level incredibly improbable. such that either it's only probably developed once here on Earth, or there's some other principle at work whereby if it can arise, it will arise, which kind of sounds like your principle at some level, Lee. But he was also very critical of the typical sort of happy chance coincidence kind of theories. He said that's just not really a viable option. So we're going to go to a break just shortly, but here's a name, and I don't know if any of you have come across this. Probably Perry, you might want to speak to this. Someone who people keep saying I should get on my show to talk about this issue is James Tour, who I believe is a US professor of nanotechnology. And from what I've heard, Lee has put his head in his hands, which I guess suggests the way he feels about this name. I'm coming to this as a layperson, but I've heard people saying, Jim Tour, he's your man, because he says he knows his stuff, and he says it just isn't going to happen in a naturalistic fashion. There has to be some kind of design going on, an input of information right at the beginning. All right, before we get to Lee, who looks very... who has had an interesting reaction to that name. Perry, what's your position on Jim Tour and what he's saying in this debate?
Well, I admire anybody in academia who's willing to go against the grain and call a spade and say what he really thinks. Because frankly, I think most scientists are afraid to do so. He's a chemist. I'm an information guy. He and I have had brief conversations. We kind of speak different languages. So, I'll let the chemists duke it out about chemistry. But what I would say is that a lot of origin of life people make it sound as though, well, all we need to do is get a little replicator started and it's all going to go from there. And most of the time they're being dishonest even about the word replicator. Well, if you want to replicate the way a cell does, you have to have symbolic code that stores information about how the organism is supposed to be put together. And that's completely different than RNA strands making copies of each other, which is kind of like crystals forming. And so I gotta say, there's a lot of dishonesty in the origin of life field, and James Tour is saying what he thinks, and I at least salute him for doing that. And I'd be interested in hear what Lee has to say about the specifics. In fact, maybe Lee and James could have a debate on this show.
Maybe they could.
Fantastic.
Maybe they could. But we're going to go to a break for now, and then we'll hear what Lee has to say about James Tour, and we'll come back shortly, talking about the origin of life, the mystery of the origin of life, and whether chemistry can crack it. Lee Cronin, Denis Noble, and Perry Marshall are my guests on this week's edition of Unbelievable.
If you listen to Unbelievable with Justin Briley on Premier Christian Radio and enjoy the conversations between Christians and skeptics, then this is the perfect app for you. For the latest updates, podcasts, videos, articles, bonus content and much more, download the Premier Unbelievable app today.
It's been such an interesting discussion today. Can chemistry crack the mystery of the origin of life? My guests Lee Cronin, Denis Noble and Perry Marshall have been with me. Lee, before we continue the conversation, where can people go and find out more about your fascinating work?
Just go to croninlab.com.
croninlab.com.
Yeah, just
Great.
one word, and there's all the papers and news there and the way to contact me.
Fantastic. I managed to watch a little sort of mini documentary, I think it's a couple of years old, about you and your family and your search for the origin of life. One bit that amused me was you were all sat around the dinner table or doing some activity with your little kids. They're probably a bit older now, but and you asked one of them, where did humans come from? And one of them said, God. And then the other, I think younger one, piped up, no, don't be silly, God doesn't exist. And I thought, I wonder where that's come from. But I mean, this takes us neatly to the question of design. The design hypothesis, you've said, well, look, we need to look at it at least. We can't dismiss it out of hand necessarily.
Sure.
And it sounds like people like James Tour, who, as I say, isn't here to defend himself, but as far as I understand it, he kind of fits with a kind of intelligent design view that actually you cannot get a naturalistic explanation that does justice to the origin of life. There's too much improbability, too much complexity. You've got to have a kind of input of information right at the beginning. What's your overall reaction to him and to those kinds of theories?
I'll give you one word: nonsense. But let me just unpack it. So James is a really accomplished chemist. He's a great designer. So he loves designing molecules, and he's good at it. Where I think James has a problem, and where I think let's take it at face value. Let's make there's three possible things that James is trying to do here. Number one, he's just trying to provoke people just to see how they react, which is fair enough. Which I guess he's probably doing, but he clearly doesn't understand information or the mathematics, because the statements he makes are contradictory about complexity and how things emerge. But I think Perry is right about the origin of life, kind of the way it's pitched. But I wouldn't say origin of life is disingenuous or being dishonest. I think they are not explaining the narrative and what was properly, and they're just building a narrative. And what I find problematical is these people then argue against creationists to say, you're creationist, that's clearly not correct. But yet the origin of life people require so many random things to not be random that you're almost a creationist for the origin of life. So I find these two communities arguing one another, and I'm like, guys, you don't understand information theory and the emergence of this. So what I would like to do, and Jim is not here to defend himself. He's a wonderful designer. Of course he's going to say it's too complicated. But let's look at the experiments that will demystify that and help us give us some information to know whether it's possible to create information. And I think that one thing I would like to pull you and Perry up on is you discussed it and said, well, it's impossible to create information. No, it isn't. That's the point. You're not creating information. You're creating randomness without teleology. When suddenly that randomness finds a use, it is then trapped and promoted, and that process is the emergence of encoding and decoding. And it's so super exciting, because I think I will be able to convince Perry and Denis and anyone else who cares that we've got systems that can do that, and more importantly, we can start a wider debate to put the limits on how much have we cheated. Because isn't me having a lab and a robot, that's cheating. Am I putting information in? That's cheating.
I mean, interestingly with you, Denis, I've often felt that you have some common cause with the intelligent design community, because both you and the intelligent design folk, the Discovery Institute and so on, have an enemy in the neo-Darwinian kind of explanations. And I know that a number of them turned up to kind of be at, your Royal Society conference.
Indeed,
where you were looking
about 20 of them,
at new trends in evolution. Now, this, and obviously Origins of Life all plays into this as well. So do you have any sympathies yourself with that particular way of getting at the issue, the design hypothesis, or do you think it's a dead end, as obviously Lee does?
I think it's a dead end for the following reason. It isn't actually useful. I don't take the view that scientific theories are ever completely proven. They can be disproven. I am a Popperian, just to use the technical philosophical phrase for that. I think we can disprove things. We never completely prove something. In that sense, there's always a bit of mystery to science. We're still asking questions, and we resolve one question, we ask it more questions. Now, the real function of theory in science is to be useful. What experiments would you do because you think this theory is worth testing? That's my touchstone. Now, the difficulty with the intelligent design view is I can't see how you'd ever test it.
Right.
I mean, it's really saying, as it were, you'll never do it, and Lee will never do it. Now, I take the view that the only way to make an advance is to try to do it. Now, I also think that it's true to say that what life does is not just to exist. You used a phrase earlier on, Lee, which was, it's what life does that is important. And I think that's got the point. It is the process. Now, there's something we know about processes. I don't know exactly how Lee's self-replicating salt works, but I suspect there's a bit of a whirlwind there in some way or another that contains the information that keeps the thing going. We see that with weather formations already. That's what the spot on wherever it is, Jupiter or wherever, also tells us. there are things that do naturally arise, and once they arise, and this is the key to them, they then harness the molecules that are in them to continue that process.
But in a sense, it's still chance that gets to that point, but it's not these vast improbabilities you're saying, Lee, that some people paint it as. That you're saying that once you get something that works, it's going to kind of grab onto other things that sort of work.
It's about trapping chance, and what happens in the molecular level is basically lots of things can happen. And so you've just got lots of possibilities and molecules, lots of different states. And what happens when that chance gets trapped, that acts as what we call a template, like a template for an archway. And that can make a really small archway, and you can get there randomly, but suddenly you have an ordered structure. All you need is stuff and energy. Now you've got that archway and stuff and energy. You can make another bigger archway. It makes a template of a template of a template. And before you know it, you've got a complex self-replicating system that has emerged from no information. And that's what we've just proven. And it's being published right now. You can get it on the archive.
Wow.
And it is the first ever spontaneously arising, I'm going to use a technical word now, called an autocatalytic set. First predicted by Freeman Dyson and Stuart Kaufman. So they're both very excited that this occurs, because the problem with autocatalytic sets today, now I'll tell you about them quickly for your listeners. An autocatalytic set is a bit like a mutual carpenter. So let's just say you're going to go and buy tables and chairs, and you can't buy a table and chair separately. And what happened is that in this case, the table makes the chair and the chair makes the table. Together they make each other. They don't make each other independently. There's a little bit of assembly. And these are thought to be the first systems that will lead to evolution. But we've only ever seen them in very complicated pieces of nucleic acid, DNA, RNA, or very complicated proteins. And these are way above the information threshold. So once again, you have to have all that information. No one has ever shown the emergence of replicators coupled from randomness. And what we've done is we've used this to generate an entirely new nanotechnology. So suddenly we can make molecules, really small molecules, into a nanotechnology using this salt and understand how it exists to harness it for other devices.
Perry, where you're a Christian, you're the only Christian among the three guests I've got on the show today. Where does this leave you and the God question? I mean, was it always were you always going to be happy if a naturalistic explanation, was posited? Do you feel this has any implications for the, I guess, uniqueness of life, if Lee may be correct?
Well, the signature moment in my journey was discovering Barbara McClintock and finding out that a corn plant could edit its own DNA, and finding out that bacteria could chop their DNA into 100,000 pieces and rearrange them. And I suddenly realized that the whole intelligent design argument, the way it's traditionally made, is focusing on the wrong thing, because they're saying, well, God is out there and God did this thing. And as an engineer, I completely understand that argument. But then when I found out that, well, a cell edits its own DNA, it's sort of like an M.C. Escher drawing where a hand is drawing a hand, then it's a whole new ball game. And to me, as an engineer, a universe that works that way is way more impressive than a universe where God has to show up and push buttons. Okay. And so I felt like the science was being misrepresented by both the neo-Darwinists and the intelligent design people. In fact, I was kind of astonished that the intelligent design people weren't talking about it, but they weren't. And so I just take that and I wind it back to Origin of Life, and I say, well, what if that's the same sort of thing? We know that a corn plant can edit its own DNA. What if there are laws of physics that can cause information to emerge? Well, that's a dang impressive universe. And so I still have my sense of wonder, and I still believe in God, and you still have to explain where it all came from. But it makes the whole system just that much more impressive.
Perhaps it does in your eyes, Perry, but I suspect for you, Lee, you'll take your Occam's razor to that system and say, well, no need for God. It all explains itself. Thank you very much.
Well, I'm not sure. Me discussing my religious leanings and using that as a way to kind of dismiss others is not productive, because I think what I think Perry is saying quite nicely is, look, he wants to keep his sense of wonder. I have a sense of wonder in the universe, and I happen to not use religion to have it. But I mean, I would maybe adopt what Carl Sagan saying. I mean, maybe in the end, Perry's God is the same as my God, but my God is the physical universe, and I'm just like, wow, look at it unfold. So I do not. Lots of scientists don't like the argument with to have the argument with intelligent design, because they feel that their words are going to be somehow misrepresented and put back against them, and I find that problematical, because there are lots of religious people that have beliefs that are very smart, that want to understand how much of those beliefs can be falsified. So if the belief can't be falsified, so if something can be falsified, I can bring it into my Occam's razor world and away I go. If I can't falsify it, then I am entitled to believe it and just have a belief system there. But I think that science and religion don't touch in that way. They're mutually compatible. I don't believe that, this is why I get angry about the origin of life people not correctly accounting for the complexity of their molecules, and then dissing intelligent design. Right. Because they're basically both making a narrative, which is not falsifiable.
It's a really interesting way of putting it. Look, it's just been such a fascinating programme today. Thank you all for being on. Where might people be able to find out more about your work as well, Denis? What should people be typing into their search bars in order to find out more about?
Well, the easiest answer is just type Denis Noble.
Well, that's a good
your
start.
Google, but with one N, not two.
There you go.
There was a 2N Denis Noble who was a very great baritone. Yes. I am not a great baritone.
we don't want to introduce any false information into our intelligently designed searches. Anyway, look. It's been great fun. And of course, Perry, if people want more about Evolution 2.0 and the prize, where can they go for that?
EVO2.org. EVO2.org.
Well, I'll make sure that all three of you have the links as well from today's show. You can find that over at the webpage, premierchristianradio.com/unbelievable. It's been an absolutely fascinating discussion. So Lee, Denis and Perry, thank you very much for being with me today.
Thank you.
Great pleasure.
Thank you.
For more conversations between Christians and skeptics, subscribe to the Unbelievable podcast. And for more updates and bonus content, sign up to the Unbelievable newsletter.